Thank you. Hi, everyone. Can you hear me okay? Cool. My presentation up. Awesome. So, hi again. I think I've introduced myself briefly in the panel discussion before, but just before I get into my talk, I wanted to give you a little bit of a background about myself. So my background is actually in engineering. So I did electrical and electronic engineering, and since I started working at Microsoft, I've started working with machine learning and artificial intelligence, but more from a software side rather than robotics that I used to do before. And part of my job is to talk to a lot of companies. A lot of them are very, very small, so startups to the biggest corporations around their strategy in machine learning and artificial intelligence. And what that actually allowed me to do is get an okay picture, I would say. It's probably not a complete picture about where the industry is at the moment and how different companies perceive data, machine learning, and AI. And hopefully, I can share some of these experiences with you today, and you'll find that interesting. So, like a lot of other people today, I wanted to give you maybe my perspective about artificial intelligence. And I am a strong believer that artificial intelligence means something completely different to everyone. As a lot of concepts out there, artificial intelligence is a particularly difficult one because it can mean a lot of things. So when I say artificial intelligence, I typically talk about intelligence agents and machines. So machines that are able to have some sort of cognitive abilities that can be similar is very, very important, or equal to human intelligence. And the reason I say it's intelligence agents in machine, because they can be robots, but they can also be stuff like chatbots, for example. So entities that exist in an online environment that you can interact with and don't know if it's a person or not. So for example, the famous Turing test, that test for artificial intelligence, the Turing test involves a person talking with an entity, an agent, the difference is that you'll have a human on the other end or a machine, and you don't know, you can't distinguish between the two of them. And the reason why is important, because you don't see who is behind that machine. You can only talk to that machine. And that's how Alan Turing basically coined the term of artificial intelligence. So a really, really interesting thought processing, and I really like to think about this a lot, is we all understand what artificial is, right? Something that humans have created, does not naturally occur in the world. But what does intelligence mean? And we can go into this, but I found the definition that I really wanted to share with you because I find that really well summarizes this whole concept of artificial intelligence and where hopefully we as an industry are aiming to go to. And this is that the intelligence is the ability of an agent, individual, human, machine, to acquire and apply knowledge and skills. The acquiring bit is very, very important because this is the concept of learning. This is the process by which you make sense of your environment, you figure out if you're looking at a person or at a chair, you figure out if you're working straight or if you're having a conversation. You're learning how to talk, you're learning how to think and to problem solve. But once you've done all of this learning, how do you actually apply those knowledge and skills in the environment? How do you interact with humans? How do you help them be better what they're doing, or how do you replace their jobs potentially? So this definition in a way very nicely encompasses the two key parts of artificial intelligence. One of it is learn, acquiring skills, and then once you've done that, being able to very effectively apply that in the environment that you operate. So there's a lot of hype about artificial intelligence. I'm sure you're aware of that. And every single technology has a hype cycle. Some of them make it through, and a lot of them actually fail. But I do believe that artificial intelligence is here to stay. It can be this iteration, it can be other iteration. I don't have a crystal ball, so I can't tell you if this hype of artificial intelligence is going to lead to a stable technology. But what I know and what I see is that this new hype of artificial intelligence is actually powered by 3 previous hypes that we've seen and people have talked about in the past 2 to 3 years that are now starting to become established technology. And a lot of those technologies are stuff like Internet of Things. So Internet of Things is not a hype anymore. People sort of accept it's here and it's here to stay. Big data, so people are handling volumes of data and are knowing how to deal with all of those problems much better, much faster nowadays, and also machine learning. But because there's so much hype, it's sometimes really hard to understand what people mean when they say artificial intelligence, or where you see a marketing campaign that says we're offering artificial intelligence solution to our customers. What I really find myself, or to explain to people or companies I work with, what are the actual boundaries of all this magic that people talk about. And to really help with this, I wanted to introduce 2 key concepts in artificial intelligence, and that is weak AI and strong AI, like the Terminator. And the reason these 2 concepts are very important is because weak AI is about building some very specialized systems that are able to mimic human intelligence. So stuff like expert system, like Paul mentioned this morning, is a very good example of weak AI systems that are extraordinarily good at performing a very specialized task, but they're not really good to transfer that learning to something else. So for example, if you have a chatbot, and chatbots are all the rave nowadays, if you have a chatbot that's able to reply to customers' inquiries, for an e-commerce platform, let's say Amazon has a chatbot, for example, and you're able to ask the question, that chatbot will not be able to automatically learn about different websites and answer questions there, because that's not how it works. It's just really good at what it's doing, but it has a very constrained domain. And that's what weak AI is about, and that's where we are now. When strong AI comes into play is this idea of a more general artificial intelligence, entities that are able to cherry pick different parts of their learning and their environment and combine that into something very similar to a mind. So rather than mimicking a human mind, you're able to reproduce something that's very close to a mind. And again, a mind doesn't have to be necessarily a human mind, but it has to be something that perceives and acts intelligently. So we're definitely not even, I don't think we're even close to strong AI at the moment, but this is definitely the place where the industry is trying to get to. So let's talk about some current trends. So we've seen that there's intelligence everywhere. So in every single conversation, every system you get marketing and sold, people are starting to talk about how they're embedding intelligence from data into their application. And there's a lot of trends that either help this artificial intelligence hype or parts of it, right? So the biggest one is cloud computing. I think without cloud computing, we'd probably not be able to talk about artificial intelligence and machine learning now to this extent. Because if you look at the way machine learning and deep learning, for example, used to be created before, it was mostly around institutes, right? Research institutes, big universities used to have these massive supercomputers that you as an academic had to go and book 2 hours on Tuesday and run your experiments, get the results, spend the week doing it, so on and so forth. But let's say a developer in their basement will never have access to that power in that supercomputer. Now with the cloud computing, you have a supercomputer at your fingertips. It only takes 2 minutes to spin up a VM, a container, and start getting your experiments. So the ability to have all this computation so much faster is actually powering this intelligence trend. Big data and IoT, as I mentioned before, big data and IoT are generating so much data that we really need AI to make sense of. Machine learning and deep learning are again, techniques and methodologies to predict the future. So you build predictive models that are able to help you figure out what's going to happen in the future, and hopefully you'll have a better idea how to deal with that when the time comes. GPU hardware is very, very interesting, and I don't have a picture of it, but if you look at the NVIDIA stock price over the past 2 years, you see that was like super tiny, tiny flat, and then in 2014 or 2015, it started skyrocketing, right? So I'm really, really sad I didn't invest it like 3 years ago, but you have to like see what's next. So GPU hardware is powering the deep learning revolution, is reducing training times for a lot of the progress that we see nowadays. And this is very, very important, because without good hardware, we would not be able to have the very cool, fancy apps that we have today. Cognitive APIs. So cognitive APIs are machine learning APIs and machine learning models that have been pre-created before and people can use very, very easily. And they're pretty general, right? So stuff like IBM Watson, for example, the Microsoft Cognitive Services, the Google Machine Learning APIs, all of these allow you to embed very, very hard to solve problems into your application with literally 2 lines of code. And examples of that are face detection, emotion detection in pictures. So being able to look at the person's face and see if they're sad, if they're disgusted, if they're angry, so on and so forth. Once you start going past cognitive services, a lot of people ask, this is very similar to what I want to do. So if you look at something like computer vision so the Microsoft Computer Vision API, because that's the one I'm familiar with, can identify over 2,000 objects, right? So if you take a picture of anything, you're probably going to be able to say, that's a plate, or that's a chair. But then some people are, okay, that's a plate, but I want to know what food is on that plate. Can you do that for me? And I'm like, I don't think so. So once you go past that, it's being able to have these general models and starting to take those models and customize them to your problem. And that's actually possible now. So at the Build conference last week or 2 weeks ago, Microsoft announced a custom computer vision API that you're able to build your own images and train whatever machine learning model you want on top of that and recognize those specific images. And I think that comes back to what Paul was saying, this idea of buy and build, and some buy and build, and being able to have something that you can actually buy, which is an API or get for free, and able to customize that to suit your business needs. And then the next thing that's going on nowadays is this idea of bots. Who in this room never used a chatbot? There's a couple of people. Don't be shy, it's okay. There's a lot of chatbots on Facebook Messengers that you can use right now, or on Skype, and I help build some of them that are available. So what chatbots are supposed to be are conversational interfaces where people can use natural languages to communicate, ask questions, and get some services back. And the reason these are useful is because they automate a lot of very expensive tasks. So stuff like a person calling and say, okay, I can't find my password. How do I unlock my account? And then a customer service person that's hired has to go in and like type in the search box and get it, copy paste it in and push it through. That can be automated, and that's being automated at the moment. And apparently with even using not machine learning, but just very, very like high-level APIs, you can get rid of 80% of your phone calls, and those can be done automatically by a bot, which is a pretty huge saving, both in terms of cost, but in terms of time as well for the personnel that can start doing more interesting stuff. And then the next bit is AI to replace humans, and I think we covered this into a lot of depth in our previous conversations. Just maybe one thing to add there, I think AI is going to be, at least in the next couple of years, mostly all about automation. And automation has replaced humans very quickly. Like, look at the industrial revolutions. We had these huge machines that replaced thousands of workers. I mean, everything before used to be done manually. You used to have people like sewing stuff and gluing things together when you do this project, and those jobs disappear overnight. I think we did pretty okay since then, so I'm pretty sure if that huge displacement is gonna come overnight with AI, as humanity. We're probably going to survive it. So let's look at where we are today. So the next two things I want to talk about is where we are today and where we are, I personally think we are headed in the future. And because there's a lot of hype about artificial intelligence, I love the fact that there's hype, and I'm very enthusiastic about it because more and more people are actually trying it out. It's very, very important to be able to discern between what people think it can do and what it can actually do. And the reason I think this is very important is because there's a lot of stuff that you can do with machine learning. Some of them are easy, but some of them are very, very hard. So a lot of customers come to me and they say, Bianca, look, we want you to help us. I know you have a lot of great tooling, so why don't you take my data and give me some insight? I was like, I wish I could do that, because if I could do that, I could probably not be here right now, but somewhere on my private island. The whole point is you can do a lot of those insights, but it doesn't happen by magic. Machine learning and artificial intelligence is not a black box that you use to dump your data and get a lot of magic out. It's actually a lot of work that people need to go and do to get those insights. So you typically start with your data set. So you have data. Probably everybody has data nowadays. You need to look at that data, clean that data, make sure it's in the right format. Then you have to decide what type of model am I trying to build, what type of problem I'm trying to solve. Once you do that, then you go through this iteration process where you're trying to figure out what's the best algorithm you're going to use to solve your problem. And then there's this whole beauty of active learning that everybody's talking about now. Things that are becoming better all the time. Natural language processing APIs that learn as you go, and so on and so forth. And this is all great, and you can really do that. But if you want to implement your machine learning model yourself, this is not automatic. You'll have to build every single part of this process yourself. You're going to be able to maintain it. And that's not necessarily very hard. It just requires you to know about it and then start experimenting with it. And I think that's the biggest thing I would say I see in the industry. Even though there's a lot of talk in machine learning, a lot of companies, at least in the UK, are experimenting with it. So a lot of people are trying out different models, how to do and predict different things, but very, very few of these projects are seeing the light of day just because some people expect it to be very easy and is not as easy as they thought. So where are we heading? So that's where we are today. I think we're making fantastic progress. I think more and more companies I talk to have a lot of ideas and have a lot of use cases that they're starting to deploy with machine learning. But where are we heading? Is it going to be an AI revolution? And I hope so. I definitely do. But at least in the next 2 to 3 years, what I see is a huge amount of automation that's going to happen due to the current technology. And we can see that with bots. We can see a lot of business processes being, in a way, automated for the past year. And in Microsoft UK, we have, for example, like 20 bot projects coming in every month, where people actually implement this bot and push it into production. So these are not fantasies, these are things that are happening at the moment. In the short to medium term, I think is going to be a more disruption, and machine learning is going to be that technology that people are going to start to use to do these predictions. And in the long term, who knows? Hopefully we're going to have this whole idea of artificial intelligence. But overall, I'm an optimist. I do believe artificial intelligence can be used for good. But I'm also a realist. I don't want to say it's going to be used for good if we just let it go by itself. I think we need to make sure we constrain it enough, and we need to make sure we put some safeguards into place. And also, I think, I don't believe that AIs are here to replace humans. I think AIs are here to amplify and complement humans. So I want in 5 to 10 years to work with an AI that says, actually, you should not go to work today because you're not going to do anything useful. Maybe you should relax, and that's going to be a better use of your time. And I'll be like, okay. Or this is not what you need to eat today. You're doing almost no exercise. Maybe you should not eat fries or pizza and have this salad that I've just ordered for you, and now it arrives, so you can't send it back. So it's all idea of having an environment that's there to help you, is there to make you a better version of yourself, and is there to amplify your capabilities. So let's look at some AI examples, and there's a lot of great examples, and there's a lot of ones that are very commercially available, and there's a lot of them that are there just for fun. And I like a lot of the just for fun example because it really showcase the technology. So I don't know if you've ever heard of whatdog.net. That's actually live now. So whatdog.net is an application that was built by Microsoft Research as an experiment. So what they did is they built a neural network to recognize breeds of dogs. So the whole point would be that you'll take a picture of a dog and the neural network will automatically recognize what breed it is. And unsurprisingly, it does much better than humans, because how many people in this room can recognize all breeds of dogs? No? No one. Yeah, me neither. I have no clue. I know like 3. The whole point is that this is a very, very specialized expert system that neural network does amazing at. And what they've started seeing in their experiment is that people were taking pictures of other people, right? So they're not putting dogs through this system. They're taking a picture of their wives or their sons or their daughter or their sisters to see what type of dog they are, because that's hilarious. Then what Microsoft Research did, is they figured that one out, so they tweaked the algorithm. So now the application is actually going to tell you what sort of dog you are. So if you don't put a person or a dog in, it's going to tell you, no, you haven't added a person or a dog, so we can't tell you the breed. But if you add a dog or a person, it's going to be able to tell you so. So that's actually pretty fun. What I'm trying to say is that it's actually a very, very hard, difficult computer vision problem. But a lot of people use this sort of application to make it obvious of how hard this technology has become. So past the fun examples, there's a lot of applications of artificial intelligence and machine learning in a wide variety of industries, and I wanted to very, very briefly touch upon some I've worked on. So in healthcare, I think healthcare is all about using AI to either reduce costs or improve accuracy in detection of a lot of diseases. So for example, in the UK, the National Health System is a very, very huge system, but it has a lot of problems, and there's a lot of those problems that could be solved by using artificial intelligence. For example, predicting the length of stays of patients in hospitals. So if you're able to predict how many people you have now and how long they're going to stay, you can predict if you have enough beds or if you have enough staff. Do you need to hire more nurses? So the way it happens is that typically if there's too many people in the hospital, the NHS is going to panic, so they have to bring more consultants in, and that's more expensive, especially if you do it on short notice. So what you can do is predict if there are going to be enough and plan in advance. And because you have this dynamic demand flow coming through, it's much easier to make a cost save and effectively use your resources. So retail. Retail is a very interesting one, because in retail it is more about customization. It's about understanding your customer better. Who is your customer and why are they buying anything from you? A lot of people can get a little bit freaked out by this. And the reason is because all these algorithms are starting to know you better than you know yourself. I.e. they know exactly what you want to buy, when you want to buy it, and they start recommending you stuff that you never found otherwise. So a lot of times if you go to online retailers or e-commerce sites, it's very hard to discover of projects because you're not physically in the store, so you can't like browse the entire shop, which means a lot of people get bored quickly and they don't go through the entire catalog. That's why recommendations are so powerful, because they allow people to discover exactly what they want to buy. Manufacturing. Manufacturing is highly related to this field of the Internet of Things. So it's about monitoring and alerting about state of different equipment. So once you know the state of your equipment, if your machinery is okay, if it's being broken down, you can start doing some interesting stuff such as predictive maintenance. And predictive maintenance is very, very interesting because it does massively reduce costs if it's implemented properly. And the reason for that is that, for example, if you're an elevators company or any type of company and then you sell that product, you typically attach a maintenance contract to it, which means that you're going to have a person physically go into that elevator every 2 months to check if it's okay and to see if they need to do any repairs. And a lot of that is actually doesn't help at all because the elevator doesn't need any maintenance. So rather than doing that, you can predict that it's going to break next month. So you schedule a maintenance just before that happens, rather than schedule all this maintenance session in advance and wasting a lot of time and money. So the banking industry is very, very interesting because a lot of the stuff, the banking sector has always used data to make better decisions. Trading, looking at frauds, calculating credit risk. All of these things have been there for a very long time, but what machine learning and AI can do is actually improve and make all of these things better and more holistic. So doing stuff like online fraud detection and predicting credit risk is a lot of the applications that the banking sector are looking at for machine learning to improve. Right, so if you're a company and if you want to start with artificial intelligence or machine learning today, where should you start? And I think you should start with your data, either the data you've gathered in the past or your data you want to gather. And if you're in the brilliant position of having gathered no data, which a lot of startups do, then that's really good because you can flip the problem on its head. You can think of what you're trying to achieve and then starting gathering the exact precise amount of data that you need. That's very, very important because a lot of companies have done this data bagging process. So they don't know what they're going to do with data, but they just store it for the past 10 years just in case. So you have all these mountains of noisy data that people really don't know what to do, and that's where stuff like big data comes in. So I think every company should look at the data they gather and start thinking what they need to process and the sort of machine learning problems that they solve with. And the easiest way to do that is to get inspired. So a lot of problems that companies solve are very, very similar. So a lot of my companies typically fall under the different verticals. You know, almost all of them, if they're in banking, will look at online fraud detection. Almost all of them that are in manufacturing will want to start with predictive maintenance. So there's a lot of patterns of how people start, and they just get inspired because they go to talks, they go to conferences, they talk to people. They're like, oh, this company is doing that. Maybe we should look at our data and do the same. So I think this is the best way to think of use cases. And you can start up untapping the potential of your own data very soon. Right, so we covered bias in AI. And I know my view about it is that we need some methodology to do it. So if you're a data scientist, and that's a lot of the stuff I do, a data scientist is typically a person that will work with data and create models and do a lot of data analysis. You have a very, very common methodology that's called cross-validation that helps you essentially test how your algorithm is going to do on unseen data. How is it going to do in the future when you release it into the wild? I would like to see something very similar for bias. Just having something like that, one of those methodologies that can say, actually, you might want to look into this data. You might want to exclude gender from your data. You might want to exclude ethics, nationality, so on and so forth. Because it looks like if you just change that one thing, you're probably completely changed. I don't think that would be hard to do. I just think nobody's doing it at the moment. Business idea, right away. So what are the challenges with artificial intelligence? So they're not problems, they're just challenges. So I think we touched upon them today. So there's some things about the actual industry movement, so stuff about ethics and safety and privacy and data protection. And these are things people need to be aware of because there's a lot of data regulations that people don't associate with machine learning. So for example, the new EU regulation, the GDPR, has a lot of extra rights of people that serve data to your company. So one of those very, very important things is the right to be forgotten. Right, so you as an individual, when you serve the data to your company, you have the right to tell that company, forget me from any single system that you've had before. How do you forget people from machine learning models? You use their data to make that smarter. How are you going to forget them? That's an important question to answer. So this is the sort of questions that keep me awake every night. So that's sort of on the technology side, but I think there's some challenges that companies face when they're starting to implement machine learning or artificial intelligence within their own company, and the biggest one is culture. And the reason I say is because a lot of companies come from the tech industry, so they have a team of developers, or they have database administrators, or they have people that are analysts and do data analysis. So a lot of times people expect machine learning or AI to be exactly the same process or the same way of implementing stuff, and it's completely different. There's a lot of uncertainties you need to deal with. It becomes much easier if you get the right help, but it's something to be aware of. Don't expect it to be exactly the same. It's going to be a little bit different, but it's going to make everything just much more exciting. The other thing that people sometimes struggle with machine learning AI is the outcome and the value. So from a lot of the talks, you will hear is, oh, we saved 100 million. Oh, we saved 200 million. What they don't say is the amount of failed experiments they had to do before they reached that saving. So no single company will start their data and AI experiments with millions of pounds, euros, dollars saving. They will start with months of just data scientists in a corner pulling out their hair, not knowing what to do because the data is just too much, too complex. So there's a lot of work that you need to do before this magical value comes, so just don't be scared. And a lot of people are going to have to make that decision in the past 1 or 2 years to invest in data science, machine learning, and AI. So I would say do it sooner than later because you'll gain a lot of expertise. And then the next one is that it's time consuming. So contrary to popular beliefs, and a lot of this hype does accelerate that is very, very fast, and there's a lot of tools, and there's a lot of out-of-the-box rabbits that you can follow around and implement these things with. It's actually quite time-consuming if you want to do it properly. But again, you don't have to implement machine learning. You can just do a chatbot. If you want to do a chatbot, you can do that in a week. So we've had customers that implemented one in a week, and then deploy that to production. Is very, very easy to do so. If you want to do something like just use cognitive services with our general machine learning API, that's fine. You can do that again very easily. If you want to build your own model, that's going to take some time, but it's not impossible. Great, so that's all from me. What I really wanted to encourage all of you today is to do start your AI journey today. You don't want to miss this beautiful train that's taking us into the future. So if you do have any questions, and what I love to do sometimes in this conference is people come to me and they, oh, I have a company, we do this is our data, what do you think we can do with it? I'm more than happy to do so do come and chat with us. Thank you.